So last night, or yesterday, we found that I'd forgotten part of the formula, and I went back and figured out what I forgot, and here it is. In standard deviation, in a normal z-score within a given data set, right? We use this formula where we have the data point and the sample mean, or the data set mean, and the standard deviation. Well, with confidence interval, with significance testing, we're looking at the means of samples as opposed to data points within the sample. So there's a lot less variation. And so we actually use standard error instead. The rest of it's kind of the same. We have the sample mean here that we're testing to see whether it's different than the null hypothesis. There's my null hypothesis. Or whether it's the same, or whether they make any change. And this is the standard error. Now, standard error, we know from our confidence interval formula. It's this part. This is the standard error, okay? So for this data set, my standard error that I'm going to use, because I'm testing the October against the May, this ends up being my null hypothesis, and this ends up being my sample that I'm going to use. So I would use this standard deviation and this n. So standard error for the October data set is going to be 0.88 divided by the square root of n, which is 100, which ends up being 0.088. That's my standard error. Okay. So then when I find my z-score, I'll just kind of move down a little bit. When I find my z-score, here we go. So here's my null hypothesis, or H naught. Here's my sample mean, right here, 2745, 7.45. And here's my standard deviation, which matches up with this data set, with this mean. So those two go together, okay? Or this is my standard error for this data set, okay? And then when I do all that out, this top part ends up being 0.6 over 0.088. Let's see what that is. Okay, 0.6 divided by 0.088, and we get 6 point, so that all equals 6.818, which is definitely much greater than 1.98, much greater than. So the this is essentially a z-score, right? And we know that roughly two standard deviations, or 1.98, would be a big z-score. Well, 6.8 standard errors away from the mean is a very large z-score, and there is a very low probability of this being part of normal sampling error. If we'd gotten something like 2.1, we set our cutoff at 1.98. This is greater than 1.98, so this difference between these two, we would say, is statistically significant. And that's what we were hoping for when we did this change in the schedule. So that's one change that we are going to make. And so if you can look through the data and try that on your own, that would be great.